information, simply to help make the decision on oil exploration. We need statistical climate information, such as historical sea state statistics, ice drifts, storms, and things like that. And this is critical for the design of activities at sea. We must know, since an oil platform, for example, lives for 50 years, what happens statistically on such a time frame. We need operational information. There are people out there, and these people must be secure, meaning we need prediction on sea state, storms, ice drifts, ocean currents, and these activities can only live if we have the appropriate information 2 days ahead or something like that. So that's the third element. Then we need impact assessment. Activity affects the ocean, and believe it or not, we always make a zero-state assessment of the ocean before we operate, a biodiversity assessment, for example, and we look at the impact on these environmental aspects. And of course, satellite data contribute not only ocean color, but for example, monitoring movements of larger species by positioning is something we do in a regular term. And the last one is prediction of climate change. Since we have activities which will last decades, we need to have an assessment of what might happen if the sea level rises by 50 centimeters. It has to be embedded in the design of the platform. If the storm frequency changes, we must be ready for it. So we have all these aspects. Of course, you might think that this is all local. Yes, it is local, except that it is everywhere. We are active in the Gulf of Mexico, Gulf of Guinea, Indonesia, north of Australia, near China, in the Arctic, so that's everywhere. And also we know very well that we cannot have this local information if it's not embedded in a larger scale. We cannot describe the Gulf of Guinea if we don't have the Atlantic Ocean. So it's connected to the large scale. And the last thing is that there are people out there, we must count on the information.
Right. Tell me something before I leave you, Jean-François, this. You have mentioned that the specifications, the things, the information that you get with some of the current JSON series, European GMES, and so on, they're very relevant to your needs. Are they sufficient?
Well, the question of the gap, I think that we must concentrate on the most difficult aspect. It is paradoxically easy to get new research satellites to get salinity measurements or interferometric altimetry as compared to what we need most, which is the continuity of the information. So personally, and for our activities, we need absolutely to count on the information, meaning that the critical aspect is mechanism which transform the appropriate selection of research organizations, research series of satellites into operational ones. And it works for the atmosphere. It is evolving for the ocean. It's changing for positioning because there is a framework which exceeds the ocean. But for the ocean, it is difficult. And that's not only for satellites, that's also for in situ information. So my main gap is a mechanism to transform the key parameters, such as JSON, into long-term guaranteed services so that we can count on the information.
Thank you very much. Does anyone here want to add something before we go to the audience?
I would like really to complement what Jean-François said, because it's extremely important, this notion about data continuity. And as of now, we are already struggling for securing the start of the Sentinel-3 second flight model, which needs to fly together with the first one in order to provide for data continuity. And it's quite an essential question. In this field, I think we see some encouraging moves in Europe, because in the USA, Richard would confirm, NOAA is in charge of both atmosphere and ocean monitoring. And quite recently, EUMETSAT, which is the European Agency for Weather Forecast from space, extended his mandate to cover also oceanography. And I think there is, let's say, some move which shows that maybe one day we will go to an operational service for ocean, in the same manner as we have nowadays an operational service for weather forecast. Another factor which is important to mention is that we nowadays develop in Europe under the leadership of Mercator a new service which is called the Marine Core Service, and hopefully the result would be that in the very near future they would deliver operational forecast bulletin for the ocean, a bit in the same way we are getting from the TV and the media. Exactly. This kind of bulletin for the weather. We are far from the same level of operationality, but the idea, the concept is there, and we all should join efforts to help them in reaching this state.
You want to add something, Jean-François?
As you know, I am familiar with that. I will count on it whenever, for JSON 3, we order 3 JSONs at once.
Please, Rick.
A natural segue to the concept of marine core services and operational oceanography, and I fear a topic that we have completely neglected in the spirit of space technology and service to our oceans, and that is data communications, that we've been talking mostly from the sensor perspective, right, how we're going to measure a variety of different parameters. Arguably, one of the most successful ocean observation systems globally has been Argo, the series of floats that, through contributions by about 20 nations around the world, measure the interior of the oceans, the temperature and a variety of other parameters. It would be useless without the satellite-based data communications capability. So let's not forget about